All right, well, it looks like we'll go ahead and get started. There may be a few people logging in still, but they'll be able to join us as we get rolling here with this presentation. So today, what we're going to be covering, first of all, just for the ones that are just now joining, my name is Larry Sharp, and I'm one of the application engineers here at Chroma System Solutions. And today we're going to be talking about power line disturbances and how they affect your devices and how we test for susceptibility and immunity when we're testing using our AC sources to generate these power line disturbances, and some of the standards and the tests that are required and we'll go cover those in some detail. And before we get started, I just want to say thank you. We got a great turnout. Looks like a lot of people are joining us today. And I really appreciate you guys taking the time to visit with us and to view what we've got to present today. But more than that, it's just nice being online with this many people and kind of getting a feel for all the people out there across the country and making sure everybody's safe and healthy and doing well. I know these are difficult times, and it's sad to see what's going on in our country these days. So I wish you all the very, very best. More than that, we hope and pray for you guys that all of you and your friends and coworkers and family will be safe, healthy, and that peace will be over you for the rest of these days and guide you and help you through these rough times. So today we're going to be talking about susceptibility of power line disturbances. And what I've got covered is a few of our AC sources that have a specific type of functions and advanced features that will make it much easier for you to generate these various types of power line disturbances. So AC sources are intended to simulate basically the grid power. And any device that plugs into the wall or plugs into utility power has from time to time been interfered by various disturbances on the line. And these are referred to as PLDs, or power line disturbances. And they can be anything from a voltage variation or a frequency variation. They can be a phase shift of the phase angle. They can be waveform distortions. And they can cause various types of interrupts or changes on your device. They can cause computers to lock up or reset. They can cause medical equipment also to go through some kind of a reset or a power down. So these are concerning things that we have to test for, and there's standards that will define those for us. There's an overall standard called the IEC 61000-4, and within that there's different separate subparts to that standard that covers simulation of power line disturbances. And we've created it here at Chroma an incredible line of products in our 61500 family. And I'm going to focus on three new additions to that family of products: our 615, 07, 08, and 09. And some of the advantages of this one is it has a higher normal voltage range. It's a single phase or three phase selectable output. And it also has 0 to 350 volts line to neutral, which is much higher than most voltages and most of the standard products out there. We can also get up to for about 606 volts AC line to line. So for a three-phase unit, it's incredible. It has a frequency range up to 2 kilohertz standard with a 5 kilohertz option. And these units come in 3, 4.5, and 6 kVA power. They have great power density, 5U package at the 6 kVA level. And we also have these units, again, it can operate as a single phase, a three-phase unit. It's selected from the front. You can select through a very simple press of a button and a few controls to change the output from single phase to three phase. And you get full power, whether you're in single phase or three phase, you still get the full power rating of the unit. A lot of our competitors, if it's a 3-phase unit, when you're operating only one phase, you'll only get at single phase 1/3 of the total power. We can operate as a Y or a delta or single phase output, and it's also has programmable slew rates, voltage, frequency, phase angle controls, and a lot of other features that we're going to get into here in just a moment. And I wouldn't be doing my job if I didn't show a nice pretty picture of it. So this is our 61509. It's a great unit. I use it a lot in my demo room and test lab. And it's a great performing unit. It has some very high-end features and functions that we're going to cover with you today. So we have 10 different models within the 61500 family of AC sources. They range from 500 VA single-phase units all the way up to 18 kVA single-phase, 3-phase selectable units. And the units that I'm concentrating on, like I mentioned today, are the 615, 07, 08, and 09s. And they're the ones in that green band right there in the middle. And these have the a little higher voltage range. You'll notice in the column it says voltage line to neutral. Our older products, 0 to 300 volts, the 61501 through 505, those are all single phase output units, and they are from 500 VA to 4 kVA. Then we jump into our 3-phase units that start at 3 kVA and go all the way up to 18 kVA. And they give you a little higher extended line to neutral voltage, which extends the line-to-line voltage as well. And this is intended to help with when you're testing a 480 volt 3-phase unit. There are some standards now that require you go to a 15% plus or minus 50% variance on the 480 volt nominal. And for that, you need to get up above 570 volts or up to close to 570 volts. To do that, our units go up to 605 volts line to line. So you can definitely handle all those requirements. The specs on the unit are very great, very good compared to everything out there. One of the things that I like to focus on is the distortion. If you look down kind of a little above the middle of the page there under voltage, you'll notice here it says distortion. And we are one of the lowest distorted units for a solid state AC source. And you can see that we're down to 0.3% at 50 and 60 hertz. This unit also gives you two different models. You'll notice there's two numbers up here, a 61507 and a 61607. The 61507 family is all of the high advanced features. 61607 is more of a basic unit. It doesn't have the same features and functions as the 61500, but still has the same output voltage and power capability and frequencies. And it even operates as a DC output as well. It operates in single phase mode where you get full power at one DC output, or you can actually have 3 DC outputs on DC on each phase, and they can be controlled independently as well. So it's a great unit for versatility, programmability, and we'll go into all of those details even more. But before we do that, I wouldn't be doing my job if I didn't cover power line disturbances. That was what we're really covering here today. So power line disturbances, just to define them, are any type of disturbance that's caused on the utility grid that might cause some kind of disturbance to your device under test, or it could even cause damage to the device in some cases. So what causes these different types of things are anything from, Mother Nature, or an accident, somebody hits a power pole. But other things that cause it are typical operations of the grid itself by the utility companies. Utility companies have to switch in and out various parts of the grid when utility linemen are out there working. So when they shut down a portion of the grid, it can cause a sag or a surge when you decrease a certain amount of load to the grid. Also, any other type of changes to the grid that might be caused by something like a major shutdown of a large piece of equipment, that can cause what's called a sag or a surge. Typically, when you reduce the load, the voltage will surge. When you increase the load, the voltage will sag for a short duration. And that can be anything from 1 or 2 cycles to multiple cycles. There's also brownouts and power outages. So what I've given you here is a little overview of what those are with a little brief explanation. But transient surges, these are things that occur when a sudden change occurs. This could be caused by a lightning strike somewhere down the line. It could be caused by a sudden capacitive load change. And these can be oscillatory, meaning it'll oscillate or ring, or it can be just a sudden spike, which will give you either a high or low voltage spike. And it can occur in much less than a cycle, even less than a half cycle. Voltage sags are any drop in the voltage from the nominal line voltage. It'll sag down. The sags can be as much as 80% of the rated nominal voltage. Below that, you're getting into what's referred to as a brownout. Voltage swells or increases, again, they can be 80% or even more. And under voltage and over voltage are where the load or the line is running at a lower voltage than nominal for a longer period of time than a normal swell or sag. Voltage interrupt is when the voltage shuts down, and it can occur as a short duration, up to, from a half cycle all the way up to multiple cycles, even minutes. Noises and notches, these are things that typically will occur like a transient. Noise is generated typically by electronic devices that anything from possibly electronic ballasts or, even power supplies, various types of electronic gear that has power conversion or power rectification on the front end of it, can inject both noise, notches, harmonic distortion. Frequency shift is something that'll occur occasionally when the grid is being switched between two different, the utility companies do have the ability to switch from different power generators. So when they're switching between that, there may be a slight shift in frequency as well. Any of these things can cause problems to things such as computers. You can cause data loss. You can have outages. Your computer can lock up, reset. It also can affect things like overheating of motors. It'll affect lighting. It'll give you flicker or dimming of the lighting. So all of these things have been defined in a standard, and that standard is the IEC 61000-4. And within that, there's multiple variations of test requirements, and I'm going to go through those in detail in the next few slides. So Chroma embedded all of these various types of features and functions into their 61500. And again, these can be done manually from the front of the unit. Most of these can be done, except for there'll be a few I'll mention that you have to use the software for. But the software that we've added is also a great general user interface to make it very easy for you to access, graphically display, and verify and save and recall your settings. So it's a great tool. It's something that we offer with our 61500 family of products. So within this, there's going to be various screens that I'm going to go through, and they go through various types of features and functions, and I'll explain those in more detail. So the other thing that you can do with this is you can also report generator, you can collect data, and you can also test specifically IEC 61000-4, 11, 13, 14, 28, and some other variations of the IEC 61000 standard, and we'll go through that in detail as well. It also gives you the ability to edit and save and recall waveforms, and to run sequentially up to 100 sequences, and these can all be stored internally in the internal memory on the AC sources that we're going to be showing you today. So the 61500, this is a 61509, has one feature known as programmable sequences. And programmable sequences gives you the ability to do some very unusual different types of voltage variations, frequency variations, ramps, and even waveform changes. And as you can see here, I've shown a screenshot here of the actual software. The software is a lab Windows software package. It's completely standalone, executable. You don't have to have NI LabVIEW to operate it because it's fully standalone. And you can see here on the right side of the screen, I've taken a screenshot of the output of the actual AC source when I ran this test. And you can see it duplicates the information that you see on the screen perfectly. And you can do sequences as small as 100 microseconds. That's what's the incredible programmability of this unit. So if you just want to create a very narrow notch within a waveform, we can do that. Or if you want to create a longer duration, we can go up to 30 seconds per sequence, and each sequence you can go up to 100 sequences, and you can repeat these up to 9,999 times to create some pretty incredible tests for your device. So programmable sequences, I covered this already a little bit. Here's another view of a waveform that we created. The nice thing about it is it gives you the ability to control each sequence independently. It even gives you the phase angle for start, and it also allows you to do different waveforms. And again, you can do this in very small incremental changes, less than 1/2 of one cycle, less than 1/4 of one cycle. So you can create some very small interrupts. And you can inject, again, various types of waveforms, and we'll go into that in more detail as well. You can do up to 100 sequences, and the repeat count, I may have misquoted it. It says here 15,000 repeats. I was thinking it was 9,999. I'll have to verify that for you. But either way, it's a long amount of repeats that you can do. This shows you a little bit of an expanded view of some of the parameter settings. So you can, in each sequence, each individual small piece, up to 100 of these sequences can be stored and saved. Each sequence can have a start degree phase angle. It can have a start and end voltage if you want to ramp the voltage up and down within the sequence. You can vary the frequency all the way up to 2 kilohertz on the standard unit, and then all the way up to 5 kilohertz with the option. You can also do a DC level voltage, and you can do a DC offset by adding it plus to the AC. And you can select between waveforms, and there's a place in the original settings where you can select which waveform you want to be, A or B. You can do each time in cycles. If you want to create perfect cycles, you can do that. You can do it in 1/10 of a cycle increment, or you can do it in time, in real time, and like I mentioned, all the way down to 0.1 millisecond. You can also do this manually. You don't have to have the software to do it. I created the same exact waveform here. These are screenshots of the front panel on the unit on the display. These are where I would go in and manually set up this particular test. So you can see here in the screenshot below from the oscilloscope, we did 3 cycles, 3 60 hertz cycles. We did those at 120 volts RMS. And right here you can see that I set that up. I set my start and end to 120 volts, frequency to 60 hertz. I set no DC offset. I used waveform A, which was a sine wave, and I did it for 3 cycles. And with that parameter setting, that's the cycle, that's the sequence that I get. And the very next sequence, because these sequence auto trigger, we can also change the trigger level, but this one would auto trigger, meaning when it finishes, it would go to the next sequence. This is sequence 0, and this is sequence 1, and it goes from 0 to 99 sequences. In the second sequence, I kept the 120 volts, I kept the 60 hertz, no DC, I kept the 0 degrees, and I changed it to waveform B, which had harmonic distortion that we had predefined for that waveform, and I did it for 1 cycle, and that's this cycle right here, where you can see the harmonic distortion. The very next one I did was a dropout. We set the voltage to 0. We did it for a half cycle, and that's this portion of the waveform that you see right here. Now, I didn't have enough space in my slide to show all of the different screenshots, but the very next sequence that we did, we changed the start angle to 180 degrees. So you can see now we're starting on the negative portion of the half cycle. And then we completed it with 2 more cycles. Then we went to a higher voltage. And these are very easy to set up and run, either manually from the front of the unit or through the software. The other thing we can do is what's called pulse mode. Pulse mode, we can inject pulses while the unit's operating. And this is a nice way to inject interrupts or various harmonic distortion by changing the waveform. Phase shifts, you can inject phase shifts as well. And any of these things can be done by doing all of the parameter settings you see here, which gives you a duty cycle for the pulse that you're injecting. It gives you the phase angle degree where you're going to start the pulse at. If it's going to be at 90, 0, 180, you can set it in 0.1 degree increments. You can set the period of time, so you can inject it, and then you would have a period of a total time where it would go back to normal operation. And with that, you can save and store these internal in memory, and you can recall it manually from the front of the unit. And again, this can be set up manually on the unit, or you can do it through the software. I prefer the software because it gives you this nice graphical display of what you're doing while you're setting it up. And then again, you can see here a actual screenshot of the display of what we created. You can also do just regular ramps. The ramps can be stair steps like this, and it can you can change the width of each step and the number of steps. The number of steps for this one can go all the way up to, let's see, I forget the maximum number of steps, and I should have that on the screen, and I don't. I apologize for that. But it's a large number so that you get to where it's basically almost a linear ramp. The other thing we can do is we have a built-in waveform synthesizer in the unit. And again, this is something that you can do manually from the front of the unit. You can set and create these waveforms. These are done through harmonic distortion at different levels. So here I've created this very odd looking waveform, which has the 3rd, 7th, 13th, and 17th harmonic. And they're done at different percentages. You can also set value or percentage for this, but I've set it with percentages of the fundamental waveform. And you can save these. You can save up to 6 of these internal memory and recall them at any time. You can also import them from an Excel file, and I'll go into that in more detail as well. The other thing that we have built into this unit is harmonic measurement. The unit has the ability to measure the actual harmonics generated by your unit, or if we're generating the waveform with harmonics, it can measure what we're actually just outputting on the output of the AC source. So here you can see we graphically display the harmonics. Now here I set 3, 7, 13, and 17 as my odd harmonics at different levels. And you can see right here on the display, it graphically displays the 3rd, the 7th, the 13th, and the 17th harmonic. So it captured it perfectly. We also get the raw data here for each of the harmonics. In this unit, we can go up to the 50th harmonic. I only displayed it up to the 40 because that's all I was using on this unit. We can do measurements even higher, up to the 100th harmonic on our 61500, 07, 08, and 09. We can also create waveforms, like I mentioned, by importing them in Excel. We have up to 1,024 data points to create a waveform, a cycle. And we can edit it in Excel, and then we can download it from Excel. We can also use waveforms that have more data points, and then we actually have a data conversion. It will it will mathematically convert that down to a smaller, to the 1024 data points. So if you were to capture a waveform, say with an oscilloscope, we can do a data conversion to get it into the waveform size to fit into our unit. And then you impose that data from your file. You can have multiple waveforms in a single Excel file. You just call up the column and the start index, and it will download that to your unit. And again, you can save up to 6 of these internally. On your computer, you can save an indefinite amount. And once you've done that, you inject it, it creates it, and you can run it. And this is what the output would look like if we did it. So here we created a notch at a certain phase angle. It's running at 240-degree phase shift. Let's see, 180, there we go. So we have a notch, we have a normal half cycle, we have an offset or a dead time in between. And so there's various things you can do by editing this, and we can display it as well by doing a plot of it in Excel. Another thing you can do with this is you can embed another waveform on top of this waveform. You can do that through the Excel. Here we did a capacitive ringing circuit test for a customer. And what we did is we took 2 waveforms at 2 different frequencies, and basically we embedded a portion of that waveform into the sine wave by just doing a mathematical add, or we did a macro that would allow it to impose that onto the waveform. It's very easy to do in Excel. Again, you can store these waveforms and recall them at any time. And here's the waveform we created. Here's, you can see what it did when we output it to the output of the unit. And again, this can be done on single phase or 3-phase as well, just by selecting the user waveform for any one of the 3 phases or all the 3 phases. This is what the file looked like that I created. This is within the waveform editor, we created an Excel file. This is where I imposed a sine wave, higher frequency ringing on top of a normal sine wave. And then we can also do like a notch, just go in and select a particular portion of the waveform and change the voltages down to 0. The actual waveform is not generated in real time or in real voltage. It's a proportional value, and when we download it, you can still vary the frequency proportionally. So if you wanted to run this at 50 hertz or 60 hertz or 1000 hertz or 2 kilohertz, you can still do that, and it would just be proportionally to the waveform that we've created. So it's very versatile in the way that you can use it. Another feature that I like about this unit is it has built into it some advanced features. And these are various TTL signals and analog signals. So if you're using a device like this for hardware in a loop, if you're familiar with hardware in a loop or power hardware in a loop, we have 3 independent external analog control voltages to control each of the 3 phases independently. And that can be driven from an arbitrary waveform generator or a real-time simulator, perfect for use with hardware in a loop. A device that I use a lot, or a signal that I use a lot, or there's 2. There's a remote excite signal. This is a signal that will trigger these sequences or trigger these various transients that we just talked about on the previous slides. So I can externally trigger it. I can also select transient signal, number 14 here. This is an output, and I use that to trigger my oscilloscope, because if you have ever tried to capture a transient, a small transient on an AC waveform when the unit is still running, it's very hard to trigger it. So by doing this, using the external trigger and using that transient signal, I always get my signal perfect. It captures it. I used it on a lot of the screenshots you saw earlier. So all of the things I just talked about that our R&D group have done a great job incorporating into our 61500 AC sources leads us to why we're doing these. And that's really based on the standard IEC 61000-4, 11, 13, 14, 28. These are all AC transient and power line disturbances. Within the IEC 61000, there's also some DC. We're not covering that today, but if you have any questions regarding the DC transients, feel free to give us a call, let us know. In all, the IEC 61000-4 has, I believe, in the range of about over 20 different parts to the IEC 61000-4. And they have various requirements in each one of those. Some are AC, some are DC, some are higher frequency, and some are also just to define the equipment requirement to do some of the tests for these. And we meet those requirements for these particular tests that we're going to be talking about. But we went one step further for you. We actually incorporated these tests into the software. So included in the software that we offer, we have the IC 61000-411 example. This one is a fairly straightforward test. It's referred to as a short interrupt or dip. A voltage dip or short interrupt means that the voltage is going to vary for a short duration. And with this, you can use what we refer to as the standard settings. We've already incorporated the standard settings built right into this test, or you can also define your own by using the user-defined settings. You can set the dip time in cycles, 1 cycle increments, anything from 1 cycle up to hundreds of cycles. You also have interval. The interval is the time between the dip cycle. So this would when it would go back to its nominal frequency, nominal voltage, and continue to operate. So you can set this time up for multiple counts, or you can do 1 count, meaning it would run the test 1 time or multiple times. And it'll give you the total test time, and it allows you to do a warm-up time. Some devices require that they be on and operating prior to this particular test. And that's what this time here is. This would be your warm-up time prior to injecting this. It's very easy to operate. Again, you can store and save it. You can generate a report for you. And here you can see what it does to the AC output when we inject that. Another part of this, you'll see a different tab up here called voltage variation test. And voltage variation test is just varying the voltage over time. It looks like a ramp, as you can see in the scope screenshot here. And it gives you the transient delta time, how long you want to take to go from nominal voltage down to your transient voltage. It also gives you your cycle time or your start time, which you can have like a dwell time prior to the ramp. And it also gives you your rise time, which would be the ramp itself. And then you have your interval time and your level. The level is how low you're going to drop in your transient, and then the interval in seconds would be how long you have between each version of this ramp that you inject. Easy to set up. Again, it has the standard requirements built in, or you can do user define and create your own. Another test is the IEC 61000-4-13. It has a total of 5 different parts of it, and each one of those are defined in our software with each of these tabs that you see across the top. This test is called a flat curve test. This is a distorted voltage waveform where the peak has been attenuated on this particular waveform. They have 3 different classifications for it at different percentages of distortion. And you can see here the HC output here with the distortion added on this particular waveform. It gives you a very easy setup. You can see there's not very many parameters. You just select class 1, 2, or 3, or you can select user define. It shows you the waveform, and it tells you what percentage of clipping is done at the peak, and it gives you the full runtime. And this again is set up per the actual standard. And of course, you can do a user defined if you want to go above and beyond the normal standard. Another part of this is what we refer to as the sweep-in frequency test. And this is where it uses an inter-harmonic on top of the standard fundamental frequency. And this inter-harmonic is not necessarily synchronized with the fundamental frequency, so it varies over time. It looks, in the low frequency end, it looks very much like a modulation of the output frequency, and then as it gets up to the higher frequencies, it looks like more like a harmonic distortion. So this is very something that we've included the ability to do in our AC sources, and this graphically shows you the physical test. The light blue area here is the portion of the test that's ran. So I just happened to capture it at that point in time. This is the waveform that it's showing, a graphical simulation of what the voltage waveform would look like at that point in time. And here is at that same time I captured it here on the output of the AC source. It's going to display your inter-harmonic frequency. Again, it's going to be changing. You'll notice that there's various harmonic frequencies that occur from below the nominal or fundamental frequency. So with inter-harmonics, you can actually modulate the fundamental frequency through injecting a lower frequency. So here it starts at 16.5 hertz, goes all the way up to 2400 hertz, does it in different increments, and then you'll see that display graphically as it's running the test. It's going to give you the counter, your level at that at the particular time that you're running, and your harmonic, your inter-harmonic frequency. Great test, nice display, easy to run. This one is one of the tests that are performed for IEC 61000-3-2, which is part of the flicker test for lighting, for LED lighting. Another part of that test is called the voltage frequency. It's called the individual harmonics and inter-harmonics. And what this does is it injects harmonics at different harmonics over different times at different durations. And so by doing this, it also is a test that would be performed for something like a flicker test. And with this, you can do you can modify it again by setting it up as a user-defined, or you can use the standard settings, and there's 3 different classifications for the standard settings. Here you can see that we've gone various amplitudes and at various harmonics at each one of these various steps. Up here you can see, it's hard to see because when it's running, it locks out the operator from changing the test while it's running. You can trigger it off. So it's a little hard to see, but the actual harmonics that we're running on this particular one are the odd harmonics, the 3, 9, 15, 21, 27, 33, and 39. And these are predefined harmonics per this standard. Another test for IEC 61000-4-14, sorry, let me see, yeah, is referred to as voltage fluctuations. And it's done over time, and it's done at different levels based on the classification. And here you can see it's a fairly long duration test. The test times are in minutes. The duration of each of the high voltage and low voltage transition, the upper and lower voltage transitions are displayed graphically while it's running, and it will show you where you're at within the test while it's running. It'll capture raw data for you as well. And here's an example of what that looks like when it's running, just a portion of it. Another test is referred to as variation of power and frequency, and this is basically a sweep of the frequency and then a dwell time on top of that. So it sweeps the frequency from one frequency to another, dwells for a certain period of time, and then continues back to the normal frequency. It does that with a increase in frequency, and it also does it with a decrease in frequency, as you can see here. Gives you the various levels, level 2, 3, and 4, based on different percentages of the nominal frequency, and it graphically will display that as you're running. Again, it gives you it as the actual standard test, which is defined by the standard, or it gives you the test and it's user defined as well. And to wrap it all up in one nice package is these are the various package types that we have in the 61500 family of products. Again, we go all the way up to 18 kVA with this unit here, and we can go parallel all the way up to 90 kVA, three-phase or single-phase. And with this unit, there is another parallel unit that is basically a slave unit that doesn't have any built-in controls. It's fully controlled by this unit. So it's a less expensive model. It's easier to get higher power that way. Or you can parallel 2 of these units as well, or up to 5 of these units to get up to 90 kVA. Same with the 615, 07, 8, and 9. You can parallel these units, parallel 2 units with this one, and still get all the same features and functions when they're in parallel. The 61505 is an older product. It's a great workhorse of an AC source. It's been out in the field for quite some time. It's a 4 kVA single phase output unit. And again, it can be series or synchronized for 3-phase operation with 3 units, or but it cannot be paralleled. And the 61501, 61504 also can be synchronized for 3-phase with 3 units, or but it cannot also be paralleled. So these 2 units are full paralleling and full operation when in parallel. I think we're coming close to the end of my presentation. So we're going to be opening up the chat room. It looks like you've already been, some people have been logging into chat and talking to Scott. And we'll continue on here. And I do have one other thing. Let's see if I can bring it up here. So this is, if you want more information on anything we've talked about today, feel free to call. We have local sales team, regional sales managers out in the field. You can reach them through our sales@chromausa.com. You can also go on our website, which is chromausa.com. And you can also reach me directly. My name is Larry Sharp, Larry S@chromausa.com. So feel free to reach out to us if we don't get back in touch with you. If we can't reach out to you during this presentation, feel free to email us and we'll get back in touch with you quickly and answer any questions that you might have. Again, it's been great talking to everyone. We're going to stay online here and answer your questions as they come in on chat. Please reach out to our regional salespeople out there. We have a great sales team that can help you. They can track me down. They have some kind of radar built in. I don't know how they do it, but they can find me even when I'm hiding. So if you need any questions answered, they are the ones that'll find me, and anyone else in our team of engineers that can support you. We have a great service department, a great calibration and service group, and we also have a great team of customer service people that can help you. So I'm going to stay online. We'll be answering questions for you, and we'll just keep going here until the end of the hour. And please, thank you again, and I hope you all are safe, healthy, and just enduring what we're going through right now in these troubled times. And I wish you all peace and good health, and hopes and prayers go out to all of you. I have to say that I've said this probably in every one of my webinars that I've done, but I feel like I learn a lot more from my customers than I can ever show them. But we have some incredible customers, and you guys have been so good to share your information with me, and it's something that I enjoy hearing from you, what you're doing. you know, the engineering in the U.S. and in all over the world has just been incredible with the new types of designs and equipment related to power conversion and related to all the different things that we support has been incredible, and I love hearing about it. I like learning more about it from the designer themselves and people on the line that are testing these units and the test engineers out there. So please keep in touch with us. Feel free to ask us any questions you might have, and we will make this presentation available. We also are recording this, so I believe in a day or two it'll be accessible as well. Again, I'd like to thank Scott Cumming. He is one of our regional sales managers. He's out there. He's supporting the chat, answering your questions, and directing you to various people and helping out anywhere they can.
Thanks, Larry. Great job.
Thank you. Looks like we still have a large group of people logged in, and we'll stay on as long as we up to the end of the hour here, answering questions, and be happy to I'll jump in on some of the chat as well. I would open all the mics, but we found that when I open all the mics, it gets a little too hard to hear the audio of everyone. So I probably would be best if you do have questions to go ahead and put them in chat, and that we can answer those. As I read them on chat, I can answer them here on my audio through my mic, or we can also type in an answer to you. So we've had a couple of questions about supplying a PDF version of the post of the webinar. Definitely we'll be doing that, and we'll be making that available. You can also reach out to our regional sales managers in your area. Again, you can do that by reaching out to our sales@chromausa.com, and they'll be happy to support you and to get that information out to you, or tell you where it can be downloaded either off of our website. We also post these the videos on YouTube, or we'll make them available from our website as well. Bob Grant asked about subharmonics, Comtrade playback. Yeah, we can do that. We can do subharmonics, and the playback on it is very easy to do through our if you capture that and you want to replicate it, we can do that through our downloading the raw data of the waveform to Excel from an actual CSV file from an oscilloscope, and then download it to Excel, and then we can take that and we can crunch it if needed to be to fit the 1024 data points, and then load that into our actual waveform editor. There's a lot of ways we can do it. Feel free to reach out to us, Bob, and I'll be able to talk to you a little more about how we can do that. Looks like we had a question regarding, let's see, mostly regarding, you know, getting access to the presentation. Definitely we'll be able to do that for you.
Larry, I see one from Daniel Herring about describing the analog voltage reference and how it works.
Sure. Yeah, Daniel, on that one, that's a plus or minus 10 volt AC input, or not AC, a 0 to plus or minus 10 volt waveform. It will duplicate the waveform and proportionally duplicate the amplitude at the output of the unit. And this is done by 0 to 10 volt, or plus or minus 10 volt equals full-scale output of the AC source. So if it's a 300 volt unit, then 0 to 10 volt would equal 0 to 300 volts on the output. And then, of course, amplifier gain, we can get you, I have output impedance ratings for the different models, so I can get you that on the different models. I'd have to email that to you. I don't have it in front of me at the moment. Delay, the delay from the input to the output on some of our units are as small as 100 microseconds, even as low as 70 microseconds, depending on the model. So from the amplifier input to the output is a delay of a very short delay in the range of 100 microseconds to 70 microseconds. We are using a lot of these. Some of these are used in hardware in a loop. Our regenerative grid simulator, which I had done a video on that a few weeks back. It also is regenerative grid simulator. It also has a very, very fast response, very short delay from input to output, from the analog control to the actual output. And that one runs on the larger 100 kVA unit. That one runs down to as low as 70 microseconds.
And Larry, I wanted to mention for those attendees who have requested a certificate of attendance, your local regional manager will follow up with you, whomever is registered, and get that over to you and see if you have any applications or any additional questions we can follow up or assist with.
Right. Thank you, Scott. Yeah, that's great to know. Yeah, we do have a certificate to let you know that you attended and viewed this, and we'll be happy to send that out to you. A couple of other things that we have. IEC, International Electrotechnical Commission, has their website, which includes the basic IEC 61000-4, the various parts of the standard. They break it down into a category that shows each one listed by their conducted disturbances versus radiated disturbances versus HEMP. So, if I have copies of that we can share with you, it's just a breakdown of those. It's not the actual standard. It's just a breakdown list of what standards are there and what each standard gives you kind of a brief description of what the standard is. There's another thing that utility companies have been doing a very good job with this. If you go on their website, they've defined a lot of the power line disturbances. And there's, San Diego Gas and Electric, also WEN, I believe where's WEN? I don't know where they're located. But there's a number of utility company websites if you're looking for information on power line disturbances, and they've put together some great information detailed about what causes some of these different disturbances. And I've pulled a couple off their websites. They're public websites that you can go on and get this information. So if you want a little more information on what they've been able to document as these various disturbances on the line, and what some of the causes of those disturbances were. So those are helpful to know. Well, it looks like we're kind of ramping down here. I don't see any new requirements on chat. I think we're probably going to go ahead and close this, but please see that there's still a few of you out there. Please feel free to reach out to any of us, myself, the sales team, our customer support group for post support. And we'll be more than happy to answer any questions that you might have. Also, feedback is great. I love hearing feedback. A couple of my previous ones, I got some great feedback, both positive and some things that needed correction or things that needed to be expanded on. So we like hearing that kind of feedback from you as well. We're here to serve you. You're our customer. We want to make sure that we do the best job we can to support you. So please let us know if there's something you need, or if there's something that's missing in the presentation that you didn't see that you'd like to know more about. or if there's even something that we talked about briefly, but you want a more expanded view of it, feel free to let us know. We'd be happy to get that information from you. It's good for us to know, because if you need it, I'm sure there'll be other customers out there that are going to need it as well. So keep us posted on anything that you see, hear, or would like to know more about.
Larry, I do see a question from Fred about the mill standard 704 testing.
Yes, I didn't cover mill standard. We're going to do that in a separate one, because there's quite a bit to that, and we have a separate soft panel for the mill standard. Yeah, the mill standard is a great software package. We're actually going through an upgrade on it as we speak. It's being tested and recertified. So we're going through all of that process as we speak, and we're going to be doing that probably in another webinar, because there's just a lot of information on that, and there's a lot of variations in testing required. It'll probably look similar to this one. There'll be the actual soft panel, and we'll be going through each one of those for you and showing you how those work.
Perfect, thanks.
I actually have I'll pop this up in the last few minutes, but this is the actual soft panel. It's actually running behind me here, and I've got it hooked up to one of our smaller units. But here we can go through and we can do various things. This is what I love about this unit. What's so amazing about our engineering on this product is that you can see here the distorted waveform that we're producing right now. Let me see if I can bring up my scope. But when it's running, I can actually change the waveform while it's actually running, which is, it's pretty incredible to be able to do that over. So I actually have a unit running behind me, and it's right now it's just set up for. I probably should have done this ahead of time, but but I'm old. I forget sometimes. I use that as an excuse a lot. So yeah, I mean, as I'm running, if I wanted to go in and inject a distorted waveform, you can see it happens instantaneously. It's and it can be done with the unit operating, loaded or unloaded. We can do square waves, distorted waveforms, user-defined waveforms. So it's it's just a incredible tool, and this is just the main. This is just the first slide within many screens that are built into this LabVIEW program that again, it's fully executable, does a great job. I use it. I use it a lot. It's something that I've been using for quite some time. It makes it easy to generate various tests for our customers. We also do occasionally, if a customer needs a verification prior to buying a piece of equipment, that it will operate properly, we've actually done tests for them. So this is one of my tools that I use. Sorry, I'm talking about my scope and I have it on the wrong monitor. There we go. So again, I can switch from a sine wave, I can go back to a distorted waveform, I can do a user-defined waveform. So I can do it, while the unit's outputting and running, which if you ever see some of our competition, you'll find that they can't do quite that. And sometimes it's not always changing at the proper phase angle. So these always start at 0 crossing or 0 degrees. And just that easy. And then, of course, we have across the top, these are all the tabs for all the other tests that we talked about already in the report generator. With the report generator, we give you all of these various measurements simultaneously, voltage, frequency, power, true power, apparent power, crest factor, power factor, even DC voltage and current, and surge current capability and peak current measurements, and again, reactive and apparent power. So, and you can do that on each of the 3 phases independently. You can do it in 1-second increments. And from there, you can run up to 1,000 hours of report time and store that to a text file. You know, it just, with all of this included in this unit, it just makes for a great package and great unit to test. In my past, I was a test engineer for a power supply company. I've used a lot of different AC sources for doing AC and DC, AC to DC power supplies and various other power conversion devices. And I know that coming from the guy that works at Chroma, that's not unexpected, but I really love this particular piece of equipment. It does everything I want it to do, and it does it well, and it's been a very reliable unit for us. So we have a lot of these in the field, and we've got a lot of repeat customers that love this unit. Well, I think my time has come to an end. I don't want to cut into any more time for any of you. It looks like basically all of our information on chat is slowed down to no more new requirements. So I still see that there's a number of you still listening, and I appreciate you hanging in there to the very end. So thank you all. Take care. Prayers, hope go out to everyone. And stay safe, stay healthy, and just look forward to the day when things get a little closer to normal again. Goodbye.
Thanks, Larry.
And take care.